Okay, this is section 10.6, secants, tangents, angle measures, picking up with number 17. Multi-sport field shown includes a softball field and a soccer field. If the measure of arc ABC equals 200, find each measure. So for part A, first we want to find the measure of angle ACE. In our diagram, ACE is formed by what would be a secant line here and a tangent line here. And the thing always to ask yourself is, where's the vertex? The vertex is on the circle. So if the vertex is on the circle, then we want to take half of the arc inside of that angle. Okay, so this angle, this arc right here, which is 200, so half of that would be 100. Now, for the second part, we want to find ADC. So in order to do this problem, ADC, okay, tangent line meeting here, tangent line meeting at that same point. So ADC. Notice where the vertex of this angle is at. It's outside of the circle. So when it's outside of the circle, then that means that you want to take half of the difference of the two arcs inside of that angle. So we have this arc and we have this arc. We're given this arc is 200. Subtract that from 360 and you'll get what this arc is. So 360 minus 200 is 160. Now our theorem and formula states that the measure of angle D is equal to half of the difference of the two intercepted arcs. So ABC, which is 200, and AC, which is 160. So subtract there, and you get 40. Take half of 40, and your answer is 20 degrees. Number 19, find the measure of angle W. We just got done doing a problem like this on the soccer field problem. So we have a tangent line and another tangent line, and they're intersecting outside of the circle. So if it's outside of the circle, we're going to take half of the difference of the two intercepted arcs. So the measure of angle W is equal to, well, this arc we know is 106, but we also have to find this arc by subtracting from 360. So first take 360 minus 106, and that gives you 254, and now you can set the problem up. So the angle outside of the circle is equal to half of the difference of the two intercepted arcs. The bigger arc first, 254, minus this arc closer to the angle, 106. So 254 minus 106 is 74, and half of that, oops, I'm sorry, got ahead of myself there. So 254 minus 106 is 148, and half of that is 74 degrees. Number 21. I have a tangent line. And this line is a secant line. Once again, it's a secant because it goes through the circle, intersects the circle in 2 points. Where's the vertex of the angle, though? Outside of the circle. So what do? We take half of the difference of the two arcs inside of that angle. So we've got one arc which goes from here to here, and we have another arc which goes from there to there. So you always have to set it up from the formula. The formula states that the angle is equal to half of the difference of the two intercepted arcs. Well, I don't know what xy is. I'm just going to call that some variable. We'll just call it x minus this inner arc, 103. And you have to solve for x. So multiply both sides of the equation by 2. That will clear out your 1/2. So we get 82 on the other side is equal to x minus 103. Add 103 to both sides, and x is equal to 185, which is actually measure of arc xy. Number 23. Almost the exact same type of problem, except for having a tangent and a secant. Now we have two secants. Intersects the circle in 2 points. Intersects the circle in 2 points. That's what a secant line does. So our angle is outside of the circle, so we're taking half of the difference of the two arcs on the inside of the angle. So I've got an arc on the inside of the angle here, and an arc on the inside of the angle from there to there. I know this one is 68. Let's call this one x. That's what it's wanting me to find, the measure of arc SU. And you set the problem up from the formula. So the angle, always start with that. Whether the angle is known or unknown, always start with the angle. The angle is equal to half of the difference of the intercepted arc, 68 minus x. Multiply both sides by 2. Subtract 68 from both sides. And multiply both sides by -1. And that's the measure of arc SU. For number 25, a satellite orbits above Earth's equator. Find x, the measure of the planet's arc that is visible to the satellite. So I want to find the measure of this arc right here. And these are tangent lines. And the angle is outside of the circle, that angle being 12 degrees. So, if it's outside of the circle, it's going to be half of the difference of the intercepted arcs. I have one of the arcs, but actually this tangent line would continue on here, and this one would continue on there. So inside of this angle, what are the arcs? This side and this side. So if I'm calling this side x, to get the other side, I have to take 360 and subtract x, whatever x is. So if this side were 100, then this side would be 260. If this side were 50, then this side would be 310. So I'm subtracting whatever this is from 360 to get this arc. Then I set the problem up. So the angle is equal to half of the difference of the two arcs. So what are they? They are 360 minus x and on this side x. So multiply both sides by 2. minus x, and then minus x. So that would give me minus 2x. Let's subtract 360 from both sides. In doing so, we will get 336, negative 336 is equal to negative 2x. So divide both sides by negative 2. And therefore x is equal to 168. So let's make sure that's what the problem's asking for. Yes, find x. There it is. 168 degrees. Similar type of problem on number 27. We just have to use a little algebra here. So we have a tangent line and a secant line intersecting outside of the circle. So if the vertex is outside of the circle, you take half of the difference of the two arcs inside of this angle. So think of this as a mouth, and it's opened up to this arc and this arc. So the angle, which we know is 3 degrees, is equal to half of the difference of those two arcs. So take the outer one first, and then subtract this inner one, the smaller one. Notice I'm putting that in parentheses, because if I subtract a quantity, I want to make sure in the next step that I distribute my negative sign. So I have 5x minus 6, and then distribute this. This would be minus 4x, and then minus 8. Multiply both sides by 2. Combine your like terms. 5 minus 4x is x. Negative 6, negative 8 is negative 14. Add 14 to both sides. X is equal to 20. A photographer frames a carousel in his camera shop, and that's supposed to be a P, as shown so that the lines of sight form tangents to the carousel. If the camera's viewing angle is 35 degrees, what is the arc measure of the carousel that appears in the shot? So basically we want to know this arc measure from here to here. Okay, so formed by two tangents, the vertex of the angle is outside of the circle. So when it's outside, that angle is equal to half of the difference of the two arcs, the two intercepted arcs. So the two arcs inside of this angle. And this side would extend out, and this side would also extend out. So, since I don't know what this arc is, I'm just going to call that x. But if I call that side x, remember we had a problem like this before. To get this arc, we have to subtract this arc from 360. So this side will be 360 minus x. And then you can set the problem up. And I'll have to pick up there on the next clip.